Welcome to the I Told You So podcast. I'm your host, Dr. Ben Cole. I started this podcast because I noticed an erosion of societal discourse and how normal conversations are often fueled by polarization. The I Told You So podcast offers an opportunity for healthy discourse and effective discussions. I select topics to discuss with listeners and guests of the I Told You So podcast. Listeners and guests predict what will happen in the future. I track those predictions and announce who predicted accurately when those predictions become true. The podcast offers topics where listeners and guests can participate in discussions with the goal of predicting the future so they can proudly say, I told you so. My guest for this episode is Chip Redmond. Chip Redmond is a meteorologist with Kansas State University and works with the Department of Agronomy. Originally from Ohio, Chip is a graduate of Ohio University and South Dakota School of Mines and Technology. Chip was allured into the plains of Kansas to observe severe thunderstorms and liked the area so much, he now calls it home. Having worked with Kansas State University for over 10 years, he manages the Kansas Mesonet, and that's a network of 85 plus weather stations across the state, and supports the Kansas Forest Service with predictive services. Chip enjoys working with producers and helping them understand the current and historical and future climate to improve their decision making. Chip also has expertise in fire weather forecasting, helping suppress some of the nation's largest wildfires as both a meteorologist and a firefighter. On this episode, Chip Redmond and I discuss Kansas climate and weather changes. So, Chip, thanks for joining me on this discussion today. I'm really grateful to have you on. So, let me start by asking you, what changes have you observed in Kansas weather and or climate over the last few decades?
Yeah, not being from this area, I think the most obvious change is the dynamics of the weather in the Central Plains. It is about the most consistent thing is that it's very, very inconsistent. We get extremes that occur on a weekly, monthly basis in Kansas. And when we look at climate in general, we average out those extremes. And so a lot of times they get overlooked. And so when we look at recent fluctuations, recent events, they've happened before. It's just they're relatively rare. So when we look at overall changes, we have to keep that in mind as we're measuring the extremes of both end of the spectrum. So when we look at Kansas climate as a whole, we see that there's two big trends overall. And the first is with temperature. We see warmer than normal temperatures. Very simply, we're seeing longer growing seasons and warmer overnight low temperatures. We're not talking about the high temperatures reaching new crazy insane maximums, but overall, those overnight lows are just warmer and warmer, and then we're seeing just more warmth overall. And it's most noticeable in snow, and precipitation is really the other anomaly we see, where we're getting heavy rain events as we always have, but we're seeing heavier rain events and we're seeing longer periods between those rain events. And so we're seeing more flooding, but then in between each flooding event, we're having longer drought periods. And that's hard to measure, but it is one of the most obvious trends. And then, we have to think about other storms that can really pique our interest and pique our remembrance of weather. And like December 15th is a good example of it hadn't been observed in December 15th, 2021. It hadn't been observed in our time, but we've had storms like that in the past that are big, high impact storms. And we're going to see them in the future. And unfortunately, when we look at climate overall, it's hard to pick out those events.
Yeah, so let's talk about that a little bit more. Um, I mean, in the news recently, we've heard about the hurricanes that have gone all the way up into North Carolina, and one just crossed over Florida. So, give us your input on that, and have you been watching that?
Yes, we have. And it actually has had a pretty big impact on Kansas weather and climate too. But it's hurricane season. There's supposed to be hurricanes in the Gulf and in the Atlantic. In fact, we look at the seasons where we don't have hurricanes. I can think of about 2020, I believe, is one of those years where as a result, those areas were extremely dry and they had big time drought and they had fire concerns and water issues. And so we need these kind of storms to bring the average moisture to those regions. And granted, three landfalling hurricanes, two within a very short distance of each other on Florida, that's an awful lot. And the impacts, unfortunately, are a high end, especially when we look at Helene and how it took that track up the Appalachians. But probably the biggest concern is that we're seeing these storms tend to provide historical rainfall events that we just haven't planned for with our infrastructure. And unfortunately, in places like the Appalachia, where the only place you can put a house is along the valley bottoms. And when that happens and we don't have infrastructure to take 20 inches, 30 inches of rain in a 4 or 5 day period, that results in significant flash flooding that unfortunately washes out those river bottoms. You think about how those river bottoms even got there to begin with. It's through erosion. So there's a lot of things like that take a historical rain event that can change the course of the landscape for decades and even centuries to come.
Yeah, so you talked about the changes in the weather, changes in climate, warm ocean waters, and so I'd like to know a little bit more about how you think we are observing these changes in our atmosphere.
Yeah, so observing our changes has constantly been in flux, and we do it much differently now than we did 100 years ago and 1,000 years ago. So when we look at overall changes, in the meteorology climatology world, we break everything up into 30-year periods, and then that's updated about every 10 years. And so we just recently had an update in 2020, and the next update will be in 2030. And so we keep bumping those up, and then we can capture those 30-year segments and go back and compare them. So we obviously have a lot more observations now than we did back then. And with satellite imagery, we can look at the oceans in a way we've never looked at them before. So we have a lot of new data, and we try to backlog that data and build an inventory that's similar to what we have now, but it's very challenging to do. So when we compare something 1,000 years ago, we have to keep in mind that we just don't have the same measurement method and the same data set. So, with those recent technologies, we're doing really well with analyzing that climate right now. And when we probably the hardest problem people have is they tend to pull trends of climate standards of years that people like. It's statistics, right? And so you can skew statistics, unfortunately, any way you want. And a good data set that truly represents the climate really doesn't exist when we think about it, because we just don't have consistency over a long period of time. So there's a lot of different oddities and trends, going from completely analog and using psychrometric um, psychrometric temperature sensors and mercury temperature thermometers to digital. And so those technologies have really changed the way we collect data and the way we look at data. From just historically, we used to just look at data from 7 a.m. to 7 a.m. the next day. And now we look at things more of a 24-hour period ending at midnight. And so just those subtle changes can lead to big differences in data sets. And unfortunately, we can't go back in time and create those new data sets. So we've also really expanded our weather station networks, kind of like the Kansas Mesonet, where the National Weather Service Cooperative Observer Program has been the historical method of calculating highs and lows and precipitation on a 24-hour basis. Someone would mainly go out there. Well, now everything's automated. We've got these weather stations that collect all that data. We don't need to do a lot of that, but we still need to maintain those stations to keep that caliber of quality in our climate data set. And now people can even get involved in their own backyard, where they have the opportunity to put a weather station in their backyard or a rain gauge, The Community Collaborative Rain, Hail, and Snow Network is a citizen science program that allows people to put a rain gauge in their backyard and compare it to everyone who's doing that. Well, we're talking tens of thousands of people. So that's a huge data set that in 20, 30 years is going to change the way we look at precipitation.
Yeah, I didn't even know about that. So I know several people who, I mean, I sometimes I look at Facebook to find out the people who, post what they found on the rain gauge. So that's sometimes how I measure that. It's just by looking at other people's posts on Facebook. So I didn't know that this, I guess, collaborative effort existed. So I appreciate that. Hopefully, listeners do too. So, what are the prevailing impactors on Kansas weather and climate?
Everything. Everything we do has an impact. Us as people like to think of things as standardized and normal, and there's no such thing. We put a house in the middle of a pasture. We have changed that microclimate, and that whether we want to think we have or not. I mean, obviously we like it, but it has changed it. We think about cities as a whole as a big concern where we put in giant cities. These are heat islands. They absorb heat, they hold heat, they change the weather around them. Atlanta has been known for triggering thunderstorms just because of the heat it holds in the summertime. So we do it on a micro scale thing, and especially in Kansas, we're a heavy irrigator state. I mean, we use a lot of irrigation. We release a lot of moisture in the atmosphere. Does that help us get precipitation? Not particularly, but it does modify the atmosphere around us. Um, so when we think of climate as a whole, we have to think about those small things, but then we also need to think about larger scale things. And so when we think climate, especially prediction wise, we look at things like the ocean heat content. And obviously right now we're at record heat content. We have not ever measured as warm waters as we have right now. We're off the charts. And so that's going to have an impact in our weather in the next 3 6 months to a year out, and that has a big impact on what those small changes are, as well as the big changes of the overall long-term trends in temperature and precipitation. So in the United States, we always typically shift our view to the west because most of our storms come from the west. So the Pacific Ocean has multiple oscillations that we look at. Probably the most common people hear about is the El Nino Southern Oscillation, or ENSO. It was in El Nino, or warmer than normal waters, for the last several years, and now we've recently had a flip towards neutral conditions, more normal, but now is falling to below normal, a La Nina. And people typically associate those La Ninas with warmer, drier winters, especially, as well as warmer, drier summers. And then we look at the North Pacific as well, the Pacific Decadal Oscillation. It's again, warmer waters in the North Pacific lead to a negative Pacific Decadal Oscillation, which we've been in for over the last 10 years or so. And it's a decadal oscillation, so it takes a long time to change. That highly impacts our potential for drought and drier conditions, more northwest flow across the central United States. And that's not necessarily what we want to see, unfortunately, when we think about drought or flooding, but that impacts our overall climate extremes and provides us with longer term trends of dry conditions. We also need to think about where our moisture really comes from in Kansas. Our storms come from the Pacific, but in Kansas, we rely on the Gulf of Mexico. These kind of storms, when they move across the United States, and as they move, they basically have southerly flow ahead of these systems, and they drag moisture northward from the Gulf of Mexico, and that's how we get a majority of our precipitation. So how those storms track, with a La Nina and a negative Pacific Decadal Oscillation, like we expect over the next 6 months, that tends to not allow that moisture to get northward and tends to keep us drier. So those just small, subtle things have big impacts on the plains weather.
Yeah, I really appreciate that. So it seems like we're really focused on the warming and the temperatures rising, in the oceans and how that's affecting storms. Um, uh, what about getting colder? I mean, how do we prepare for that, and will we maybe in the future have more colder weather? It maybe not just the United States, but in other regions. Can you maybe talk a little bit about that?
Yeah, so I'll focus mainly on the United States because I'm pretty familiar with it. But um, when we look at when we say we have a warmer trend, it doesn't mean we don't have cold periods, and we tend to see more extreme weather when we get this warmer trend because we get used to a warmer condition. And when we have a big system come through and it brings colder air for a couple of weeks, like we had in January of 2024, and then again in the February several years ago, we can have those really, really cold outbreaks still. We're just not prepared for them as much because we are used to warmer conditions. And so just because we have overall warmer conditions and the more ocean heat content does not mean that we are completely shut off from colder conditions. A good example is, every winter we still have the polar vortex form in the North Pole, and that moves southward slightly. Then we get these basically lobes of it that revolve around the main vortex, basically an upper level jet stream that goes around the whole northern hemisphere. And when we get lobes of that exposes us to much colder temperatures. And it is the main cause of most of our cold snaps in the central plains. And so it again, we're looking at the extremes and we have to average out those extremes to get the climate normal. So a warmer climate does not get rid of the extremes.
Yeah, so really appreciate that and your comments. Chip, I thank you so much for being a guest on the I Told You So podcast. So I'll just say if listeners want to learn more, you can find Chip Redmond on Twitter or X, and you can his handle is at WX underscore Chip. That's WX underscore CHIP, or through the Kansas Mesonet at mesonet.ksu.edu. That's mesonet.ksu.edu. So, because this podcast is about predicting the future, my questions to those listening are, how can we be better at predicting and forecasting weather in the future? And then, how can we, or even you, listener, do a better job at preparing for changes in the climate?
I'd like to answer those questions too.
Yeah, let's do it. Go ahead.
Well, as a meteorologist, predicting and forecasting tends to get, we tend to get accused of being wrong all the time and saying that we can keep our jobs. So, as we look into the future in weather and climate, forecasting has significantly changed over the last several decades. And I like to kind of call it, we were the first artificial intelligence out there because we were trying to predict what was going to happen in the future in the 80s. And we've come a long, long way since then. And our 7-day forecasts have greatly improved. And now we're to the point now where our 10-day forecasts, even our 30-day forecasts are greatly improved. Granted, we can't get information if we're going to get a big hailstorm 3 months out. We'll never probably be to that extent because there's so many small idiosyncrasies of weather and some of those small micro scale changes that are hard to measure. But as we move forward, not just with artificial intelligence, but with the global forecast models, we've moved into an ensemble approach in forecast models that basically takes one model, gives it 30 different opportunities or options, and it just runs that same model. And we just take the average of those. And we've really, really improved long term. So as you get more data points in, especially when we talk about the community collaborative, rain, hail, and snow network, a citizen science project that everyone can do. Those data points, we're putting tens of thousands of more data points in, and as a result, we are getting much better data. And so we can now look at the polar vortex out multiple months almost, and we have a really good idea of what's going on in the oceans due to satellite imagery. That has drastically impacted our forecasting. So while we have an idea when these droughts and floods are coming, for the most part, we can now actually take progressive and active steps to hopefully mitigate the impacts of those and to improve our infrastructure. And so as we better prepare for these changes in climate, we already know what we're seeing. We can validate what we're seeing, and now we can have better confidence in our projections in the future so that we can build better infrastructure to support some of these big Helene floods that, again, they've always been there. We just don't see them often enough. Um, and so in an agricultural sense, I work with in agronomy a lot, and with the wildfire sense, I work with, you know, people on the ground of what are long-term plans for the forest or for the agriculture community, and it's adjustment. It's small things. There's a lot of hype in the media about global warming and carbon credits, and there's a lot of things that distract people from the overall. We cannot take our eyes off of what we're actually observing. Look around you and observe what's going on around you and see how it's changed. Snow is a big one. People understand that we're not seeing snow anymore. So when we do get a snow event, it's big impact. We need to be better prepared for those, despite us thinking that we don't get as much snow. Invasive species is a huge one where we have to adapt. I mean, we're seeing the agriculture community adapt to cotton being grown in Kansas. It's never been grown before in Kansas. But we're also seeing things like um, armadillos and insects are moving north. They're overwintering. So we have to be better prepared to handle those increased challenges, because it's a reality, and it maybe not get distracted so much by the crazy things, but dial it down and focus on what's happening in your local community.
Yeah, really appreciate that. And my question really to the listeners is, do you agree with Chip Redmond's assessment and how he answers those questions? So I'd love to know your opinion about that. So let me know. I'd love to know your thoughts on this. I'd love to know more about your thoughts on what Chip Redmond has been telling us. And so you can call me or text me at 785-473-3721 or send an email message to me at ITYS at BenKohlITYS.com or post on any of my social media channels. So I do ask you to go to the I Told You So podcast website at BenKohlITYS.com. That's BenKohlITYS.com to connect and get your own I Told You So items at the merchandise link. You can get shirts and hoodies and hats and coffee mugs and lots of other items. The I Told You So podcast is a space for healthy discourse and effective discussions with the goal of predicting the future so you can proudly say, I told you so. Also, if your business or organization is interested in advertising on the I Told You So podcast, please let me know that too. So thanks for tuning in to the I Told You So podcast. And thanks again to my guest, Chip Redmond. And followers of the podcast are very important. So please follow, like, subscribe, leave a comment, give a high rating, and share with your friends. I'm your host, Dr. Ben Kohl, and I hope to hear from you soon.